Welcome to this installment of LabRat Scientific. Today I want to talk about multimeters, both analog and digital, to see how they can be used to measure current, voltage, or resistance in a circuit. Here's the analog multimeter. I currently have it set for 5 volts on the dial. I could put it to 25 volts, or 125 volts, or even up to 500 volts. And I have it hooked up to a power supply. And as I change the voltage, you'll see the needle point at different values. So I'm currently at 0 volts. Let me adjust the voltage up. So here we are at 1 volt DC, 2 volts, 3 volts, 4 volts, and 5 volts. Now, you can see the various scales. 5 volts here, 10, 25, 125. So depending on how I have my dial set, tells me which set of numbers I'll be reading. So here's my digital multimeter. I've got it currently set on 20 volts. I can also measure resistance and currents. But I've got it hooked up to a power supply. And now I'll adjust the voltage and see how it responds. So here I'm at 1 volt. 2 volts, 3 volts, 4 volts, and 5 volts. Take it on back down. Now it's fairly obvious that it's easier to read a digital voltmeter because it actually gives me digits and decimal points. That makes it more precise than the analog meter. Now I want to use my digital multimeter to measure resistance. We've got a bank of resistors here in my block of wood, and the resistor on top is actually a 4,600 ohm resistor. So I've set the proper scale on my multimeter, in this case 20k ohms, so it'll actually read up to 20,000 ohms. So simply put my probes onto the leads of the resistor, and you see it comes out to be about 4.65 times 1,000. So that's 4,650 ohms. So of course the resistor is not perfect, so there'll be some small variations. And if I change the polarity on the probe, it doesn't matter. I'll get the same reading for the resistance. Let's take a look at two extreme cases for resistance. The first being zero resistance. If I take my probes and simply touch them together, you'll see the meter reads 0. That means there's zero resistance, essentially in the leads of the probes for the meter. Now, if I take the probes apart, I have air as being an insulator, and that's giving me infinite resistance. Or if I touch the probes to the rubber of my rat's tail, I can see that it's infinite resistance again. No resistance will read 0. Infinite resistance will read, in this case, this 0L, which means infinity. So the rat's tail and the air are good insulators. Metal is a poor insulator and actually a good conductor, in this case essentially zero resistance. So in this setup I want to use my digital multimeter, set it amps for current. I want to measure the current going through the circuit to illuminate this little light bulb. So what I have is I have my power supply coming in through on the positive to a terminal on the circuit board, running through a switch, then through the light bulb, and then back out to a socket, which is connected to one of the probes of the multimeter. The current runs through the multimeter, out through the other probe, and then back to the ground of the power supply. So now as I crank up the voltage, we'll watch the intensity of the light bulb change, and we'll see the corresponding current change on the multimeter. So you can see the light bulb beginning to illuminate, and you see the current changing. So get a pretty intense light bulb here, and I'm pulling about 0.4 amps in the circuit at roughly about 10 volts. And you can see my switch. I open the switch, the light bulb goes off, the current drops. I close my switch, light bulb comes on, and the current jumps up. Again, decreasing the voltage, the intensity of the light bulb goes down, and correspondingly the current drops down. Okay, so let's make some voltage measurements on some common household batteries. I have my multimeter set on DC voltage. And first of all, I've got a AA battery here, and those are typically rated at 1.5 volts. So let me go ahead and measure that and see what it is. And I have about 1.5, 1.6 volts. So that battery's in good shape. I have here a 9-volt battery, and that should be reading 9 volts. And sure enough, 9.4 volts. Now, new batteries will generally have a little bit higher voltage than they're rated at. Now here I have two 6-volt lantern batteries. So let me go ahead and make those measurements and see what those voltages are. The first battery is about 6.1, 6.2 volts. And now if I look at the second battery, I see about 6.1, 6.2 volts. So they seem to be in pretty good shape. Now if I connect these two batteries in series, the negative pole from one battery to the positive pole of the other, I create a series battery, and that should give me a voltage which is a combination of both batteries. So let me go ahead and make that measurement and see what we have. And sure enough, it's 12.3, 12.4 volts. So that is a combination of the two voltages. Well, that's it for now. Hopefully you learned a little bit about how to use a multimeter to measure resistance, current, and voltage. I hope to see you next time on LabRat Scientific.